Hello, chemistry students. Today I have Miss Aarons here. We're going to make sure we save this correctly, hopefully. And we're going to do a quick little review over what we learned with our representative particles yesterday. And we're also going to teach you how to do moles to mass. And then Miss Aarons has a kind of a different way of looking at a visual concept that's not dimensional analysis. And you can choose which way you would like to do this. You get the same answer every time, just a little different. Okay, so let's go ahead and review. So let me get my pen on here. So the first conversion factor we learned about was representative particles. And we know that representative particles could be one of four things, and that was what your worksheet that you had in class was. It was either atoms, ions, molecules, or formula units. So with this, we always knew that these representative particles were always going to equal 6.02 times 10 to the 23rd. And that was always going to equal 1 mole. And we could write this either way, and you guys were doing some calculations using this. Okay? So this is not changing. Okay, you're going to really have to read the problem now and see if it's asking for representative particles like molecules, atoms, formula units, or ions, or if it's asking for mass, because there's conversion factors for both. So now on top of these two conversion factors, or this one that we can flip, we're going to add the ones for mass. So representative particles, and there's only two types of mass. There's atomic mass, and there is molecular mass. Molecular? I meant molar mass. Atomic mass is just for one element, and molar mass is for a compound. And we had some practice calculating molar mass on Friday. Yeah. We did a worksheet, and so hopefully this isn't a brand new concept for you. You've had a little practice for it already. Okay, so let's go ahead and look at these conversion factors. If you have, let's say we have 14 grams of calcium. Okay, and we want to know how many moles that is. Okay, so we're looking for moles, and this is really, I always do this like little shorthand, just what I'm starting with and where I'm going. Yep. And then I start my problem. I know you guys hate writing because it's so much work, but it really helps you stay organized, and staying organized is probably the biggest thing in these next two chapters. If you don't know where you're going, you're going to be lost. So we're going to use 14 grams, and since we just have calcium here, we know that we're going to use this atomic mass unit because it's just one element. Okay, if it said calcium hydroxide or something, then we'd know we have to calculate the molar mass. So here we're going to put grams of calcium on bottom, and the only place we can find grams of calcium is where? Periodic table. Periodic table. So what's the atomic mass of? 40.098. Okay. 0.078. Okay, and that is always equal. Whatever the number on the periodic table gives you is always equal to 1 mole. Okay, never any more, never any less, always 1 mole. So this is something that is equal. Okay, and so now we're just going to take this and we'll do a calculation here. Let's get our calculator out. Okay, minimize this. Okay, so we're going to have 14, let me erase that, 14 divided by the 40.078. Okay, so we're going to get 0.3493. 3493. Okay, and grams cancels out here, so we are left with moles of calcium, okay, because that's what you have left, so that's the units that are going to carry over. Okay, we'd want to use 2 sig figs, so I would say that 0.35 would be the correct answer here, and I would box that in, right? All right, so now let's do another example, and let's flip this guy. Okay, we can flip this guy around, and we can solve for the amount of grams. Okay, so we'll say we have 12.2 moles of carbon. You can put always 1 mole of carbon on bottom, always 1, and then instead of solving for representative particles like we did yesterday, now we're going to put grams on top because we want to go to grams, and so we would use 12.011 grams of carbon, so it'd be 12.2.
So oh yeah, 12.2 times 12.01.
Right, and she multiplied because these are on top. Let's not forget that from yesterday. So 146.53. So 146.53. And it looks like we need 3 sig figs. Sorry, so that's going to round up to a 7. So 147. And then we're going to move that over 2 times. 10 to the second to have our correct sig figs grams of carbon. Don't forget all of your label. Okay? Alright, so let's do an example of molar mass here. And to do molar mass, now it's going to be the same thing. Let's do maybe 15 grams of calcium hydroxide, and we want to go to moles. So to do that, we would just take the 15 grams of calcium hydroxide, my bad, sorry. And now we have to calculate the molar mass of the calcium hydroxide. So calcium is what, 35? Oh, 40. 40.078. Oxygen is
15.99.
and hydrogen is 1.0079. Okay, and so if we bring up the calculator again, we do 40.078, and then we add it to 15.999, and then we add that to 1.0079, and that didn't give me a point in there. That was going to give us a big number. We would get 57.09, and that is equal to 1 mole of now the compound. Now I saw a lot of you yesterday not writing out. You just put 1 mole. Always write out what's behind here. Yeah.
Because it labels it for you.
Yep, it labels it for you. So now grams of calcium hydroxide cancel out, and now we just do 15 divided by 57. And we just do clear 15 divided by 57.09. And that's going to equal 0.2627. Moles of calcium hydroxide. And of course we'd only need 2 sig figs, so just cancel those out. Box my answer. Being slightly lazy there, but. Alright, and the last one, let's just reverse this. Let's go from moles to grams of a compound. So maybe this time we do a molecule, maybe like P4O10. Okay? So we want to know, let's say there's 0.5 moles. Sound good? So we just write out our given number, 0.5 moles. And we would put 1 mole of the P4O10 on bottom. And now we're going to put the molar mass on top. So P4, P is what?
30.973.
Plus 10 oxygen. This is going to be a pretty big number, yeah? So let's go ahead and bring up the calculator. And we got 4 times 30.973 equals 4 times 30 1.73 equals 123.89. And then times 10 is going to make this, oops, 999, right? Or 159, right?
Yeah, I'll remove it once. There you go.
What we're doing here. Just kidding. Okay, so now let's add that together. So 123 plus 159. Oops. 1. Thank you. 59.9. So we get 283.88. And now we can do our calculation. So we just take 0.5 times that answer by 0.5. And we get 141.941. So we need 1 sig fig. So it would be 1 times 10 to the second. Wasn't very precise. Probably should add some more sig figs right here.